Alright, in this video we're going to discuss how to use a computer program to analyze lipofuscin. This is a program I wrote that quantifies it. It uses R and a mixture model. And basically this is RStudio. It's a front end for R, the program. It's still a little challenging to use R, but for your purposes and this program, there's really, it's not going to be too difficult. So the first thing you do is you load in this program. You're going to open a file, or and then the very first time you run this program in R, you have to install these packages. Now, I have actually used this hashtag to comment them out because I've already installed them. I don't need to do it again. But you can either get rid of the hashtags or just highlight on the other side of it and hit this run button. There's a run up here that lets you look at that. So, So once you've done that, the other thing that you need to do is you just need to fill in the directory where your picks are located. So I suggest that for the examples that we're doing, you just create a new directory, subdirectory, and this is just the name. Notice the direction of the slashes, and notice that it ends with a slash. So be sure to get this whole thing in there. Single quotes around it. There's a C at the beginning, but you just need to put in this with the hashtag, or with the those little slashes going in the correct direction. It matters which direction they are. So put that in. Notice that at the bottom that directory is labeled path. And we're going to send to path an answer file, which is text. So, so once you've done that, basically, and you've got your pictures in this directory, then basically I Control A and click the run button. And then we get these little, and with these picks, we get these invalid TIF directory. This is because the way that the TIF file is created on the Zeiss just creates this problem. It actually doesn't care. You just have to do it a couple of times for each one, and it will go through and do the analysis. You can tell it's working down here because these are the 5%, 50th percentile, 90th percentile of the illumination things. And it's running them. I have no idea what that means, but oh. Yes. This is funny. I filter the files for TIF files in this directory, but I have the word quantification in there, and it finds that one. And oh well. So it doesn't hurt anything. Now we're done with that. Let's go to our directory. Let's look at our test file that has been copied down. And it's a file that looks like that. Let's go into Excel, open a new file, and let's drag our TIF file, or our test file, into there. And then we have a file that's a text file for each of these, and so we need to convert to columns. So I am going to data, text to column. It's delimited. Next. Oh shoot. Let's try that again. Highlight A. text to column, delimited, next, comma, next, finish. And then we have the output. Now, that file we just did, oh, I forget what the mean was, but I figured out the mean. The program said it was 112. It's going to be pretty close. I don't remember what we found earlier in the manual, but that's the way it is. That's all there is to it. This is the magic column right here that tells you how much lipofuscin there is. That's it. Thank you.